Lesson: Continuous integration and deployment pipelines for AI. Continuous integration and deployment pipelines have become indispensable components within the lifecycle of AI model development and maintenance. These pipelines ensure that AI models are not only developed efficiently, but are also deployed and updated in a manner that maintains high levels of performance and reliability. By integrating CI/CD practices, AI professionals can deploy models in production environments swiftly and accurately, while minimizing the risks associated with model deployment. The implementation of these pipelines is underpinned by a suite of practical tools and frameworks, each offering unique capabilities that enhance the deployment process. The foundation of any CI/CD pipeline is continuous integration, a practice that emphasizes the frequent merging of individual developers' work into a shared repository. This practice is crucial for AI model development as it ensures that models remain up to date with the latest changes, whether they involve improved algorithms or updated datasets. Git, a version control system, is often used alongside platforms like GitHub or GitLab to manage these integrations. These tools provide robust features such as automated testing and code review workflows, which are essential for maintaining the integrity of AI models. Automated testing is a critical component of continuous integration for AI models. It involves the use of scripts to automatically test the functionality and performance of models whenever changes are introduced. Tools like PyTest and UnitTest in Python are commonly employed for this purpose. They enable developers to write test cases that validate the correctness of model outputs, ensuring that new code commits do not inadvertently degrade model performance. This is particularly important in AI development, where even minor changes can have significant impacts on model accuracy. By incorporating automated testing into the CI pipeline, developers can quickly identify and rectify issues, thereby maintaining high model quality. Once a model has been successfully integrated with the latest changes, the next step is continuous deployment, which involves the automated release of the model to a production environment. This stage is where tools like Jenkins, CircleCI, and Travis CI come into play. These platforms offer capabilities to automate the deployment process, from packaging the model to deploying it on cloud platforms like AWS, Google Cloud, or Azure. For instance, Jenkins provides plugins for Docker, a containerization tool that packages applications with their dependencies, ensuring that AI models run consistently across different environments. Containerization is particularly beneficial in AI deployment because it encapsulates the model and its runtime environment within a container, eliminating the "it works on my machine" problem. Docker containers can be deployed on Kubernetes, an orchestration platform that manages containerized applications. Kubernetes automates the deployment, scaling, and management of Docker containers, making it easier to handle large-scale AI deployments. This orchestration is essential for AI applications that require high availability and scalability, such as real-time data processing models. Real-world implementations of CI/CD pipelines in AI projects highlight their effectiveness. For example, Netflix employs a sophisticated CI/CD pipeline to manage its recommendation algorithms. The pipeline automates the integration of new features and the deployment of models, ensuring that the recommendations remain accurate and relevant as user preferences evolve. This approach allows Netflix to continuously improve its recommendation engine without significant downtime or user disruption, demonstrating the value of CI/CD in maintaining competitive AI services. Furthermore, the concept of infrastructure as code complements CI/CD pipelines by enabling the automation of infrastructure provisioning and management. Tools like Terraform and Ansible allow developers to define infrastructure using code, which can be versioned and integrated with CI/CD workflows. This integration ensures that the infrastructure required for deploying AI models is provisioned consistently and reliably, reducing the chances of deployment failures due to misconfigured resources. A notable challenge in the CI/CD pipeline for AI models is the management of model drift, which occurs when the statistical properties of the target variable change, leading to model performance degradation over time. To address this, monitoring tools such as Prometheus and Grafana are used to track model performance metrics and alert teams when performance falls below acceptable thresholds. This proactive approach allows for timely model retraining and redeployment, ensuring that models continue to deliver accurate predictions. The integration of CI/CD pipelines in AI development also requires a cultural shift towards DevOps practices, which promote collaboration between development and operations teams. This shift is essential for overcoming the siloed nature of traditional development environments, where communication barriers often lead to deployment delays and errors. By fostering a culture of shared responsibility, DevOps encourages teams to work together in automating and streamlining the deployment process, ultimately leading to faster and more reliable AI deliveries. In educational settings, the implementation of CI/CD pipelines in AI courses can provide students with hands-on experience in deploying and maintaining AI models. This practical exposure equips students with the skills needed to navigate real-world deployment challenges. For instance, courses that incorporate platforms like Google Colab or Jupyter Notebooks can simulate CI/CD workflows by integrating code testing, containerization, and cloud deployment exercises. These activities prepare students to implement CI/CD pipelines effectively in professional settings. The future of CI/CD and AI model deployment is likely to involve increased automation and the adoption of more advanced tools that leverage artificial intelligence itself to optimize pipeline processes. Machine learning algorithms can be used to predict potential deployment issues or to automatically tune model parameters, further enhancing the efficiency and reliability of CI/CD pipelines. As these technologies continue to evolve, the role of CI/CD in AI deployment will become even more integral, driving innovation and improving model performance across various industries. In conclusion, the implementation of CI/CD pipelines in AI model deployment is critical for achieving efficient, reliable, and scalable AI systems. The process involves a combination of tools and practices, including version control, automated testing, containerization, and infrastructure as code, all of which contribute to seamless model integration and deployment. By addressing challenges such as model drift and fostering a DevOps culture, organizations can ensure that their AI models remain robust and effective in dynamic environments. As the field continues to advance, the role of CI/CD will be pivotal in shaping the future of AI model deployment and maintenance.